And welcome back. One more part to section 5. We had to split it up. I know it was a little long. So we previously talked in this last section about the impacts on society, deaths. Now let's talk about cost. So what you see here is a list of the top 15 most costliest in billions earthquakes and associated events. Number 1, 2011 earthquake and tsunami that hit Japan. Magnitude 9.1 earthquake. We haven't had many of those in recorded history, only a handful. $360 billion worth of damage, almost 16,000 deaths. A lot of that from the tsunami that ensued, that was triggered by the earthquake. Same with the cost. Japan also comes in at number 2 for 1995. The U.S. comes in 4th with our most costliest one in 1994 in Northridge in California. A measly $49 billion, only 57 deaths. And what you'll see here, again, in a lot of hazards, they inversely affect poor people more so than, or poor areas or poor nations than wealthier nations or wealthier areas or wealthier people. So for instance, in 1999 in Turkey, $19 billion, but 17,000 deaths. Where in Italy in 2012, pretty much, along the same lines of cost, but only 18 deaths. Yes, it depends on what happens, where it's at, the preparedness, but yeah, so like Haiti, again, $14 billion in damage in that 2010 earthquake, 316,000 deaths. Same in China, lower on the cost, even up here, but much higher in the deaths. Whereas a country like the U.S., again, $10 billion, very low deaths. It's the unfair advantage of wealthy versus poorer nations, unfortunately, I guess. So as far as the U.S. costliest earthquakes, 1 and 2 are mentioned in the previous slide. But if you'll take a look, 8 of the top 10 are in California. Washington in 2001 is up there with $2 billion worth of damage. And there's 1 death, but that person had a heart attack. So take that as you will. So you can see in the U.S., even our most costliest, there's not a lot of deaths. The one kind of sticking out here, well, that happened in 1906 in San Francisco. Things weren't built like they are today. People aren't as prepared as they are, today, or even into the 60s, 70s, 80s, and today. So this is well over 115 years ago. And a lot of those deaths were also associated with a fire that kind of ripped through San Francisco after the earthquake, that secondary hazard. But again, in an area of wealthier nations, you get more economic impact, cost, than you get deaths typically. So, with the bad comes the good. What are some benefits of earthquakes? You ever thought of that? What are benefits of earthquakes? Think about it. Let it rattle around your brain. Well, it is. Let me give you another part of the super secret code while I remember. It's the number 7. You got me? The number 7. One more time. The number 7. So some benefits, or sometimes referred to as natural service functions. Geologic faults provided by earthquakes or produced by earthquakes, they really influence the underground flow of water, oil, and natural gas. So they can trap or channel some of these substances into certain areas, collecting them, and then for later to be explored. A lot of times, again, oil and natural gas are going to be found near faults. Just because there's an avenue for some of this material to travel through rock to get collected. So faults, and which are create earthquakes, can dictate the flow of material underground. You can as mentioned in a previous section, faulting is also, or where faults are located, is also a great place for mineral-rich water to seep into to deposit different minerals that are mined out. Faults can be a source of economically valuable minerals. So for mining, so beneficial to mining. They can form scenic landforms over time. You ever thought about that? Like, oh wow, because of stuff moving around, it forms this cool scenic landform. They do. So it kind of aids in landforms and tourism as well. Additionally, the benefit of earthquakes is that they might prevent other earthquakes. So instead of a lot of energy getting stored up, I don't want to break it. Instead of a lot of energy getting stored up and then released all at once, if you just have a bunch of smaller earthquakes, if that's more common, the way the faulting or the way the plate movement works out. If you have frequent small earthquakes, well, that might prevent larger ones because you're releasing some of that energy. You're not letting it build up. So, earthquakes prevent earthquakes? Yeah, actually. Small earthquakes, repeatedly can prevent bigger earthquakes. What about humans? Can we cause an earthquake? Some of these hazards we'll talk about in this class can be directly tied to humans, wildfires, and a number of other things. Some not. But can earthquakes be tied to humans? Can humans cause earthquakes in what we do, what we build in our activity? What do you think? Well, the answer is yes. So the action of people have caused earthquakes in kind of three main ways. Loading the Earth's crust above a fault. So sometimes faults, we don't know they're there. Perhaps they're underground. Maybe we think they're sleeping and or dormant or even ancient faults. But if we put a lot of weight on top of something that's broken, big slabs of rock that's broken, it could cause, that's a lot of force, it's a lot of pressure. It could cause stuff to move, hence create an earthquake. So this happens, not a lot, but this can happen. And if it does, it's more often to happen when, for instance, building a large dam and or reservoir. You're building a large structure and putting a lot of water behind it. And water is pretty heavy. And so you get this big structure with all this water behind it, essentially putting all this pressure on the ground below. If there's any faults below, they could be triggered. Another way we have caused earthquakes majorly is in fracking. Fracking is short for hydraulic fracturing. More on that, I have a little diagram I'll explain more in a little bit, but it's a process in which we extract natural gas out of the ground. If we're pulling stuff from underground, if we're breaking up rock to get to the stuff underground, things might move. But also, there's a large amount of waste water that's created in this process, so they pump it back underground. So not only do they break up the ground, now they're essentially lubricating it by putting water in down there. Things could move. And then kind of a common sense one, if we don't do this anymore in the United States, but we used to test nuclear weapons above ground, then they outlawed that, so then we're like, okay, well, let's test them below ground, and then we outlawed that quite wisely. But yeah, if you let off a nuclear explosion big enough, it's going to cause the earth to quake. So with dams, let's touch on that real quick. Dams are actually built oftentimes on faults and maybe not really known. So let's say here's some flat land, river, and all of a sudden a fault. There was some slippage. There was an earthquake. So it looks like the hanging wall went up. Right, the hanging wall at the left side looks like it has an overhang to it, and it kind of went up. Remember what type of fault that is? Or what type of stress can cause that? Let's see. I got it right here. All right. So how can I make the hanging wall go up? If I pull apart, no, the hanging wall goes down. If I push together, yep, compressional stress making it a reverse fault. Just in this case. It doesn't have to be a reverse fault to make a dam. But anyway, so that occurred. The river erodes the valley of that fault block that was lifted up. creating a nice cliff face and a valley behind it. So the end of the valley is an ideal point along a river to build a dam directly kind of above that fault, whether it's known or not. Some of the more recent and larger reservoir-triggered earthquakes have been in India, China, and Australia. All right, so Australia, wealthier nation, 60s and 70s, actually triggering rather large earthquakes, a lot of energy released there. So that's how dams and reservoirs can do it. The dam's the structure, the reservoir is the water behind it. Eye itches. And then hydraulic fracturing. So this is something we'll touch on much later in the semester. But natural gas is a fossil fuel. And to extract it, what you typically do is drill down and that material, that natural gas is under pressure because it's so deep underground. So essentially you just drill down, stick a straw in the ground, a big pipe, and because all that material is under pressure, well, it'll come out. Now, there are some types of rock where you can't just do that. You have to fracture the rock, and you have to do so with hydrofracking, hydro water. So essentially what you do, in hydrofracking, you drill down, and even there's new drills where you can actually drill down and then off to the side. And then you pump under pressure, under high pressure, water mixed with chemicals. It's nasty stuff. And you pump it under pressure and it fractures the rock, allowing minute natural gas particles to be released. And then you have to fracture the rock to get the gas out, to get the gas flowing. And then when you're done, the wastewater comes out, the gas comes out, you separate the two. When there's no more natural gas, you pump the wastewater back down. But now you've created all these cracks that may be near some ancient fault. You're putting pressure on the rock around it. And now again, if you're pumping water back down, you're lubricating the whole area that's broken and maybe near a fault, creating earthquakes. And that's what's been happening in Oklahoma. They're drilling down, fracturing the rock that may be near some ancient fault that was unknown. But again, near fault systems are great places to trap natural gas and oil, also fossil fuel. But if you're kind of cracking and messing around stuff and then pumping wastewater back down in here, especially if they're near faults, what kind of fault is this one? The hanging wall went down. It's tensional stress causing a normal fault. Anyway, but yeah, that can re-engage the faults, and depending on how they're set up, you could have small earthquakes or you can have a bigger earthquake. That's all I got. We'll kind of play around with a lot of this stuff in class and the activities and the lab. So we'll give you a little more hands-on feel, especially with some of this measuring techniques, and why earthquakes might be in one area or not. Any case, it's been a pleasure. I will see you next time.